Hi everyone. So today we're going to continue our conversation on exponential growth, but we're going to be talking about it in the context of finance. So our objective for today is to solve financial problems involving exponential growth. But I want to go over one bit of vocab first before we get started, and it's about interest. If you've ever heard of interest in the context of banking, interest is something that the bank pays you if you make an investment with them. So say you want to save $500, you give the bank $500, and the bank doesn't just keep that money in a box somewhere. It'll spend it and give it in the form of loans to other people. And they'll give you interest in return. So they might give you like 5% of that 500 each year. So they'll give you 5% of your money back just for saving with them. So when we talk about compound interest is interest paid on both the original amount that you invest. So this is original amount. And we also sometimes call this the principal. So it's interest paid on both the original amount and any previously earned interest. So let's say you invested $100. Then if the bank gave you 5%, you'd have $5 more by the end of the year. Then the following year, the bank would pay you 5% of $105, not the original 100 that you saved. So you end up making more and more as the years go on in interest. All right, let's get started. Okay, so next to me is the formula that we're going to be using to calculate the interest earned on an investment. But before I go into this, I really want to advise you to take a look at the other video that I posted on how we derive this equation. It's going to make so much more sense if you understand where it comes from. But if we're just doing this, I want to show you what the equation is. So it's A equals P times 1 plus R over N to the NT. Let's talk about what all those letters stand for. So A is going to be our balance, or the amount that we have after T years. So our balance after T years. P is going to be our original amount, or our principal. So that's the original amount that we invest. Original amount. R is going to be our rate at which our interest is compounded. So this is a rate expressed again as a decimal like we've been doing. N is going to be the number of times our interest is compounded per year. So we say interest is compounded if our interest, say it's 5%, is calculated and added to our investment. That's one compounded piece. So if our interest is compounded 4 times a year, that means that the bank takes 5% and adds it to your account 4 times per year. So N is going to be the number of times interest is compounded. So number of times interest is compounded per year. All right. And T is going to be the number of years. So number of years. So say we wanted to, invest $500 at a rate of 2%. And we want to figure out how much money are we going to have in 10 years. We'd put 10 in for T. This also makes sense because A, what we're trying to solve for, is our balance after T years. All right, let's talk a little bit more about compounding interest. We really have 3 options for how often our interest is compounded. We can either compound it annually, which means that we compound it once per year, or we can compound it quarterly, which means we compound it 4 times per year. So this is 4 times. Or we can compound it monthly, which means that we're going to compound it 12 times per year. All right, now that we have all of our background information, we can do some problems relating to interest. All right, on to problem solving. So what do we want to do? Well, we want to determine the value of an investment after a certain amount of time. And how are we going to do this? Well, we're going to use the general form of the compound interest formula that we saw before, which I put right here for reference. So our first problem is that Griffin invested $1,000 at a rate of 3% compounded quarterly for maintenance funds for his car. So our first task is to just create a general equation using the compound interest formula for this situation. So we're going to need a few things here. We need all of these different aspects of our formula. So A is what we're looking for. A is the balance of our account after a certain amount of time. So A, we don't know. P, however, is our original amount that we invest. So that's going to be $1,000. R is going to be our rate of compounding interest. So that's 3%. And 3% we want to express as a decimal. So that's going to be 0.03. And N is going to be the number of times our interest is compounded yearly. So if it's compounded quarterly, we know that's 4 times per year. So N is going to be 4. All right, now we can set up our equation. So we get A, which we don't know, equals P, which is 1,000, times 1 plus 0.03 over 4, 0.03 over 4, to the N times T. So that's going to be 4T. And if we just have a general equation here, we don't know what T is yet. We don't know how much time we're going to be evaluating this for. So this is good enough. You can simplify this inner part, but I'm going to leave it for now. All right, on to part B. Part B asks us to find the balance, or in other words, the money that Griffin has saved after 5 years have passed. So all we're going to do here is take this formula that we came up with, plug in 5 for T. So we'll get A equals 1,000. And here, just to simplify things, you can figure out what this is in here. So that's 1.0075 to the 4 times T. So that's 4 times 5. So that's to the 20th. And when you plug this into your calculator, you'll get $1,161.18. So that's all the money that Griffin has saved after 5 years. That's a lot of money in interest. Look, that's over $161 in interest. All right, let's do another one. Problem number 2. Cassidy wants to invest enough money so that she'll have $10,000 for college tuition in 3 years. She invests at 6% compounded monthly, and she wants to figure out how much she should invest now to make sure that she has that money in 3 years. So we're going to have to do a little figuring out here, and we might have to do a little rearranging of our formula here. But let's figure out what we have and what we don't have. So let's start with A. A is going to be the final amount, and we're actually told something about this time. She wants to have $10,000 in 3 years. So A is going to be $10,000. That's what she wants to end up with. P, however, is our principal, or her original amount that she invests. That's what we're trying to find. We don't know how much she wants to invest right now. So that's a question mark. R is going to be our rate of interest. So our rate is 6%. That's going to be 0.06 in decimals. N is going to be the number of times we compound yearly. So we're told it's compounded monthly, so that's 12 times per year. So N is going to be 12. T is going to be how much time we're looking at. She wants to have $10,000 in 3 years. So 3 is our T. All right, let's plug this in and see what we get. So A we have is 10,000. I'm just following this formula up here. So 10,000 equals P, because we don't know what it is, times 1 plus 0.06 over 12. 12 comes from N, all to the NT, so 12 times 3. Now, we're going to have to do a little rearranging here, because what we want is on this side with all this other stuff. So let's simplify this a little bit. So 10,000 equals P times 1.005 to the 12 times 3, so that's 36. Now if I calculate this, I'm going to get something around 1.2. I want to divide this side, so I get P alone, by 1.005 to the 36th. So I'm going to divide both sides by this amount to the 36th, and I'll find that P equals about 8,000 $356. So what does that actually mean? Well, that's the money that Cassidy is going to have to invest now so that in 3 years at that interest rate, she will have $10,000 for tuition. I want to mention here that this interest rate is really high. These days, you're lucky if you get an interest rate above 1%. But it's still money that the bank gives you, so it's good either way. All right, thanks for watching. I hope you try the problem at the bottom of your guided notes. It's very similar to one that we've seen today. Thank you.